Okay, let's continue with how to conduct the final project with Excel. So previously, we talked about how to use Excel to provide descriptive statistics to various kinds of demographic variables. We didn't go through all of them because, well, it's your job to go through all of them. So I just did some examples. Um, I think what I did is sex, a nominal variable, education, an ordinal variable, and income, a ratio variable. Okay, so if you can follow the three examples, you can pretty much do um, the remaining three. Okay, all right, so let's talk about inferential statistics, how to use Excel to perform, per this project, correlation analysis, and mean comparisons. All right, so let's start with uh, correlation analyses. All right, so as instructed in the instructions, to perform correlation analyses, you need to use two continuous variables, right? That means you have to use two interval variables, or two ratio variables, or one interval, one ratio variables. Anyway, you have to perform three correlations. Okay, so I'm going to illustrate how to perform correlation analyses with Excel using two demographic variables, um, just as examples, right? You should not in the project perform correlation analyses using um, demographic variables. So, but I just use this as examples. Okay, so I will again open a new worksheet and rename it by double clicking on the default name. So that will allow me to type in um, new names. So let's call this correlation 1, right? All right, so I decide for this example to use as my first variable, um, let's say degree, right? I just randomly chose some variables. You should look at the instruction and guideline to see whether this variable is suitable for correlation analyses. But here I just randomly chose one. So degree, I will copy everything here to here. Okay, so I have degree, and then we'll copy, let's say, income. Okay, copy. So my goal then is to see whether or not education and income are related. Well, they should, shouldn't they? To a certain extent, not perfectly. Well, anyway, so with these two variables and all the values of these two variables, we can start to, as the first step, compute a correlation coefficient, R. Okay, so R equals 2, right? So you would then let the actual value of the coefficient appear in this cell so that I know that you did your calculation here. Okay, so as we illustrated in class, to request for the correlation coefficient, you in this cell type equal to correl, right? So this will tell Excel to compute a correlation coefficient, and then left parentheses. Now Excel is telling you to specify the first array of data, so that's education. So you include all the numerical values. You don't include this because correlations cannot be done with text. Okay, so you highlight everything here. So you highlight this, you can type it in a column, but then it's not A2, so you have to scroll all the way down to the last cell here, which is a 501, right? That's the last value. Okay, so that's the first array of data, and the second array of data is, well, starts with B2 and ends with B501. Okay, right, and then right parenthesis and then hit enter. Boom. Okay, 2.27. Not too bad, I would say. Okay, so you will ask Excel to display only 2 decimal points as per tradition. All right, 0.27. That's not too bad. It's sort of a medium or moderate or small, I would say weak correlation. Okay. Anyway, so okay, so the next step is to construct a scatter plot for this correlation. Okay, so what we can do is we highlight everything and then we insert a scatter plot. Okay. Is this right? Let's see. What if we just highlight the numbers? Okay, just highlight the numbers. Oops. Okay, and then we insert scatter plot. Okay, about the same. That's okay. All right, so you have here. Probably want to move this up a little bit. So, all right. So we want this chart to be here, or here. Okay, so you can name this chart correlation 1. Okay, easy enough. And then we know that these dots are data points, right? So this one data point and the second data point. It looks it surely looks like a positive correlation. Okay, and then we want a trend line. So what you can do is you go to design. There are a number of ways to do that, I believe. Okay, this is not one way. Okay, so here's another way. But the way we did in class is we add chart elements and we look for a trend line and then we chose linear. There we go. All right, so as you can imagine, it's a slightly upward positive line, so that makes sense, right? So education, income. Okay, good. So that's your scatter plot. The last step is to construct a 95% confidence interval, right? So we want to have the lower bound and the upper bound, right? So lower bound, and upper bound. Just lower and upper. Okay. So to do this, right, we need to use the spreadsheet calculator that I made for you. So it's CI for correlation. It can be downloaded from Laulima under week 15, I believe. Right, so click open it. Right, so it's a very easy interface. It has the directions, it has the cautionary note. Right, only change things in these two green boxes. Never touch anything in the orange box. So here you will enter the correlation coefficient. Here you enter the sample size. And then once you enter these two pieces of information, the spreadsheet will automatically provide you with the lower bound and upper bound of the 95% confidence interval. Okay, and here is how you would interpret the 95% confidence interval. Okay, so let's try that. We just know that the correlation coefficient we computed is 0.27. For the sample size, we'll just go with 500 because that is the sample size. Technically, it's not because you see we have some missing values. That's okay. We'll go with 500 for the purpose of this project. So 500, and then you hit enter. So we have now the lower bound and the upper bound. So the lower bound is 0.19 and the upper bound is 0.35. So you just enter the two values here. So it's 0.19, whoops, right here, 0.19 and what is it, 25, 35, 35? Yeah, 35. Okay. So now you can see, right, whether or not this 95% confidence interval includes 0 or not, right? So if it doesn't include 0, what does it mean? If it includes 0, what does it mean? Okay. Um, that's it. That's your correlation analysis 1. And then you repeat this procedure for 2 more times, right, with the variables that interest you. Okay. Okay. So straightforward. Now let's do another example with mean comparison. Okay. So again, I'll be using demographic variables to illustrate how to perform mean comparisons using Excel. But for the project, right, you should not use um, the demographic variables for mean comparisons because, well, just follow instructions. So I'm going to choose one categorical variable. So I can choose sex. Sex is a categorical variable, right? It has two categories. Two, I believe, is female and one is male. So we can compare male and female on their income level. How about that? To see whether or not there's a sex gap or sex difference in their income. Okay. Well, and the choice of these two variables makes sense because, as we said in class, one variable in mean comparison must be categorical variable, the other variable must be continuous. Okay. So let's use sex. Copy. And then we made another worksheet. So this is mean comparison 1. Mean 1. Okay. So we copy sex variable here, and then we copy income variable here. Fantastic. Now we have these two variables. We're almost ready to go. So for mean comparisons, we need a little bit more information to display. So we have the male category. Okay. Male category is denoted as 1. So what's the mean for male, right? And what is the standard deviation for male? And what is the sample size for male? And then we do the same thing for the female group, right? It's denoted as 2. So what's the mean income for female group? What is the standard deviation for females? What is the sample size of females? Okay. All right. So now we can start to filling in these blanks. But as we said in class, right? Now as the data are arranged, we can probably not perform mean comparisons because 2's and 1's are interspersed. It's very difficult to compute the means for the two categories. So what we need to do, as we said in class, is we need to sort these two data, right? These two columns of data. We must sort them at the same time. We cannot just sort one variable while ignoring the other variable because that will create mismatch, right, between these two variables, the values of these two variables. We need to sort them at the same time. So we'll go to custom sort, right? Sort and filter. Go to custom sort because we want to specify how we want to sort, right? So we'll tell Excel we're going to sort by sex, okay? And we sort on values, so these are values. And order is a ascending order from small to large. So that's pretty good. Okay. Boom. Okay, now we have all the data sorted according to sex. So we can see all the ones up to here and all the twos, right? All the way to the end. Now we're ready to perform mean comparisons. So what is the mean for male? So we want the averages to appear in this cell. So we type in equal sign average, and then we highlight all the values under income that are belonging to ones. Okay, so all the ones. Okay. Okay, so those are the values associated with male. One is male. Yes. Okay. Right parenthesis and then hit enter. Okay, so wow, the average income level for males is very high. That's surprisingly high because the highest value in income is 12, and that's almost on the top. So wow. Okay, anyway, so we need to calculate the standard deviation of incomes for male. So standard deviation SDV dot as. Okay, so all the ones. Oh, right here, right parenthesis. Okay, it's a small standard deviation, not too bad. How about sample size? So we'll count how many males are there, right? We just highlight. Okay, we'll highlight this. How many incomes do we have? Ooh. Okay, right parenthesis. Okay, there are 211 income values because there are some missing values, right? So it's not going to be the entire number of males. Okay, so now you can repeat the procedure for females, right? So females, you will be the average of all the females. Huh, okay. All the way down. There we go. A little lower, not low by a lot. 10. Okay, what about standard deviation? SKDEV sample. And all the twos. There we go. Okay, the variation for females in terms of the income is bigger than that of males. That means the distribution of income for females is more widespread than males. Okay, interesting. Anyway, so let's see how many women provided income data. So we count, and then we see how many women provided income data. So that would be our sample size for the female group. Aha, okay, slightly more than males, that makes sense. Okay, anyway, now we have these. Okay, so the second step is to construct a bar chart to compare, right? To visualize the mean comparisons. So what we can do is we highlight this, and then we highlight this. So how do we do this is we first of all highlight these two. We highlight, how do we do this? Okay, one way to do this is to say, okay, so for male is 11.36, for female is 10.79. Okay, now we can do it. So we highlight everything in this area and then we insert a bar chart. And there we go. All right, so this seems quite a big contrast because the units in y-axis is very small. We can make it not as that small. So we change the units from 0.1 perhaps to, okay, change the minimum from 10.5 to, let's say, 5. How about that? Okay. So see, because now I changed the units of the y-axis, now the difference visualized in this bar chart it makes more sense, right? It's not as huge as the previous chart suggested. We can make it slightly more apparent, maybe 8. Okay, slightly better. I like this better. Rename it mean comparison 1. There we go. All right, so that's your bar chart. The last step is to construct a 95% confidence interval for this mean difference. The mean difference, as you can see, right? The mean difference is, if we do calculation, right? 11.36 minus 10.79. How much is that? I have no idea. So I can say, well, I mean, how much is this value minus this value? All right, there we go. The difference is 0.57, and then we can construct a 95% confidence interval around these two values. So it's 95 CI equals 2. And then we have the lower bound, and then with the upper bound. Okay, so now we need the spreadsheet calculator, CI for mean difference. We open it. Okay. All right, so the mean, let's treat sample 1 as male, sample 2 is female. So mean for male is, what is it? 11.36. 11.36. What's the standard deviation? 1.74. Sample size, I think, is 2 on 1. Am I right? Excellent. Female mean is 10.79. Standard deviation, I think, is 2 point something. 2.38. Sample size 248. Excellent. Okay, there we go. So now we see the mean difference is 0.57 as we just calculated, and this is the lower bound of this mean difference, and this is the upper bound of this mean difference at 95% confidence level. So we can just, record these two values, 0.19, 0.95. Where is it? 0.19, 0.19, 0.95. Okay, now you have the 95% confidence interval, right, for this particular mean difference, and now you can start to interpret this interval. What does it mean, right? So the first question you have to ask yourself is, does this interval include 0 or not, right? If it does, what does it mean? If it doesn't, what does it mean? Okay, but anyway, so this is how you will perform mean comparison analyses using Excel, and then you repeat the procedure for another 2 times so that you have 3 correlations, 3 mean comparisons, and then another 3 tabs for the remaining 3 demographic variables. In total, you need to have 6 tabs for demographic variables and 6 tabs for inferential statistics. So that means in total, if we include the original tab, you need to have 13 tabs or worksheets for the complete analyses. Okay, so I hope this provides you a guidance for how to perform mean comparisons for the final project using Excel. Good luck.